Plastics are a true modern marvel, as they can be fashioned into just about anything from a thin film to any shape your heart desires with 3D printing. Even many of our favorite clothing is made from plastics. We wrap our food with plastic to keep it fresh and safe. For convenience, we make plastic dinnerware. We even drink from plastic bottles. But plastic has a dark side. Over 300 tons of plastic waste is generated annually, worldwide, and much of it is ending up in our rivers and oceans. Large pieces of plastic present a choking or tangle hazard for fish and wildlife. But what is the threat of microplastics to humans? Small pieces under 5 millimeters are turning up everywhere. In the soil, in seafood, and now even in human blood. My name is James McEwen, and I'm a Master's of Environmental Policy student here at American Public University. I'm also a science fiction author, environmental compliance assessor at Joint Base Lewis McChord, a 3D printing hobbyist, a business owner, and a husband and father. And I would like to invite you on my journey through this Capstone project to answer the question of what is the risk of microplastics here in the waters of Puget Sound. Since 1869, when John Wesley Hyatt created the first synthetic polymer, the world has never been the same. Hyatt's polymer was created by treating cellulose, derived from cotton fiber, with camphor. It wasn't until 1907 Leo Baekeland invented Bakelite, the first synthetic plastic, meaning containing no molecules found in nature. War pushed the need for innovation as it often does, and World War II greatly expanded the need for plastics. By the end of the war, plastics were being produced at an ever-increasing rate, and so was the waste and pollution problems. In 1969, pieces of plastic were turning up in the stomachs of albatrosses, as documented by Kenyon and Kreidler. This might have been the first documented instance of plastics ingested by wildlife, but it wouldn't be the last. As the problem of plastic pollution got worse, many papers and works were published between 1987 and 2009, many of them dealing primarily with cleaning up beaches around the world and mostly in North America. During this time, people were only focused on large pieces that they could see with binoculars or with the naked eye. The first time the term microplastics popped up was in 2004, when it appeared in Lost at Sea, Where's All the Plastic? By Thompson et al. The size of microplastics was debated somewhat, until microplastics, finding a consensus on the definition, was published in 2019 by Fias and Nash, in which a definition was agreed upon. But the short part of the story is, anything under 5 millimeters is considered to be a microplastic. Why the Puget Sound? For me, it's personal. I live here, in the city of Lacey, which is at the south end of the Sound. And I work at Joint Base Lewis McChord, which is just 20 minutes up I-5. But it's more than my personal interests. The Sound is home to a plethora of aquatic species, including 14 endangered species, 7 species of whales, 3 species of turtles, 2 species of frogs, and 2 species of fish. A comprehensive risk assessment located in the Puget Sound region. This project will seek to address the following questions. What is the hazard or threat that microplastics pose to marine as well as human life, if any? This will be accomplished by means of addressing past and current studies on microplastics, effects on marine life, and conducting interviews with environmental professionals who work in and around the Puget Sound. What type of microplastics pose a threat or hazard? This will be accomplished by compiling data from collection studies throughout Puget Sound to understand which microplastics are more prevalent in the waterways. Where is the greatest threat? Populated versus non-populated areas. This question will be addressed by means of data collection from studies already completed on the concentration of microplastics in various areas of Puget Sound. Are there any steps that can be taken to mitigate the risk? Any possible solutions? The last two questions will be addressed by interviews or questionnaires of working environmental professionals and researchers in the area. A risk assessment of microplastics in the waters of the Puget Sound region will serve to educate not only the author of the assessment, but those who read it. Researching, interviewing, and data analysis are all vital steps to the process and are also a major learning objective for the program. The risk assessment author will meet these objectives as the project follows from conception to completion. Resources needed. Microplastic studies that quantify the types of microplastics in and along the Puget Sound waterways. Studies that address the concentration of microplastics in populated versus less populated areas. Studies that address how microplastics are getting into the food web. Professional and researchers interviews. Stormwater engineers at Joint Base Lewis-McChord. Pretreatment water engineers, also at Joint Base Lewis-McChord. Washington State Department of Ecology water quality experts. Water and marine researchers at the University of Puget Sound and the University of Washington. Conservation groups to be contacted for interview: Puget Sound Keeper. The preliminary action plan. The plan will be broken down into phases. Phase 1, gather research. Phase 2, conduct interviews. Phase 3, conduct site visits if needed based on the information gathered from phases 1 and 2. Phase 4, analyze and organization of data. Phase 5, write the assessment. Phase 6, finalize and present the findings. When the project is concluded, a written risk assessment will be completed and made available to those who wish to see the results of the assessment. The end goal of the assessment is to be used as a tool to help shape environmental policy going forward at the local, state, and possibly federal level. This concludes my presentation. Thank you for joining me.